This presentation is Module 6 of Chem for Bio at Northern Virginia Community College, Annandale campus. And the subject of this module is one thing and one thing only: water. We all know that water is essential for life on this planet. It is the chemical properties and the physical properties of water that allow life to exist. And so in this module, we will go over those unique collection of properties. How important is water? Well, over 50% of the mass of an adult human body is due just to water. It cushions, it lubricates, it's the transportation system for molecules and ions, think electrolytes, and of course it is the transportation system in the elimination of waste products. We all know that these jobs are critical, but it really only scratches the surface of the many roles that water has in sustaining life on this planet. So we'll walk through them one at a time. The first one is the cohesion of water molecules. Cohesion is defined as an attractive force between identical molecules. So the attraction between water molecules, the way they stick together, is called cohesion. What causes this cohesion? Well, it is the hydrogen bonds that exist between the water molecules. Please remember that hydrogen bonds are not actual covalent bonds. They are not forces within molecules. They are forces between the water molecules. And while attractive forces between molecules are always weaker than bonds, hydrogen bonds are surprisingly strong for intermolecular forces. So water molecules stick together because of these hydrogen bond attractions. If you have a water molecule in the middle of a droplet, it is attracted on all sides to all the other water molecules around it. But if the water molecule is on the surface of the liquid water, it is attracted only to the liquid water molecules below it. This results in the strong surface tension of water. Surface tension is defined as the ability of a substance to resist rupture by external forces. So it is the cohesive forces, the cohesion between the water molecules, that cause the molecules to form droplets and allow for the strong surface tension there on the surface of a water droplet or a body of water. Well, what does cohesion do for you? Again, I just said that is why water forms droplets and don't just spread out all over a surface like oil does. But it also allows, because of the strong surface tension, it also allows larger, heavier objects to be able to float on the surface of water. Hence you see leaves floating in a pond, and you see the water striders, which are honestly pretty heavy objects relative to the water molecule, and yet they can essentially walk on the water surface. So we have cohesive forces, or cohesion, which is the attraction between the water molecules. They're stuck together with hydrogen bonds. But we also have what is called adhesion, and that is the attraction between water molecules and other molecules or other substances. And these are usually other substances that water can also hydrogen bond with. So water molecules are attracted to other charged substances like ions and other polar molecules. So you see in the figure of the spider web again, you see that the water is forming droplets, and that's due to the cohesive forces between the water molecules. But you see it's also sticking to the spider web. Those are adhesive forces, adhesion, between the water molecules and the molecules that make up the web material. This is also why when you place water in a glass tube, like a capillary tube, that the water will in fact rise up the tube against the acceleration of gravity. It is an interplay, it is a balance between the cohesive forces, the cohesion between the water molecules, and the adhesion between the water molecules and the substances that make up the glass. So you get this concave meniscus of the water in the tube. In contrast, lots of other substances, even though they may have very strong cohesive forces, they have much weaker adhesion or adhesive forces. So for example, mercury, being a liquid metal, the mercury has very strong cohesive forces. The mercury atoms are strongly attracted to each other, but they're not attracted to the walls of the glass at all. They have very low adhesive forces. Well, this balance of cohesion and adhesion is what allows water molecules to move against the acceleration of gravity in plants. If you've never asked yourself, how can water be absorbed by the roots of a plant and then travel up the trunk or the stem, up the branches into the leaves, against the acceleration of gravity? It's due to this balance between the cohesive forces and the adhesive forces. Water molecules are attracted, can hydrogen bond with certain parts of a plant cell wall. And so a water molecule starts to travel up the cell wall against the acceleration of gravity due to the strong adhesion, and then other water molecules follow that first water molecule because of the strong cohesive forces. Another unique property of water is its ability to moderate temperature in the surrounding environment. Remember that heat energy is simply the kinetic energy due to the random movement of molecules and atoms. So we're going to talk about what's special about water when it comes to the transfer of heat energy. The ability of a substance to absorb heat is called its specific heat capacity, or its specific heat. And it is defined as the amount of heat energy that 1 gram of a substance must absorb in order to increase its temperature by 1 degree Celsius. So you can literally think of it as being its capacity to absorb heat and not change temperature. Well, water has one of the highest specific heats on the planet. The numerical value is 1 calorie per gram per degree Celsius, and that may seem like a very small number, but if you compare it to the other values on the slide, you can see that water has a very impressive specific heat or specific heat capacity. Other liquids that can hydrogen bond, like alcohols, okay, they have a decent heat capacity, but it's about half that of water. And you can see that metals, which are routinely used to transfer heat, have very low specific heats. Air itself only has a specific heat about 25% that of water. So when air absorbs heat energy, its temperature rises about 4 times as fast as when water absorbs the same amount of heat energy. And that is, in essence, why so many of us want to live somewhere near a large body of water. Large bodies of water can actually moderate the temperature changes in the surrounding environment, because as the sun gives off its energy, the body of water, is able to absorb that thermal energy with a relatively small temperature change, whereas the air and the sand around it are absorbing the heat and changing their temperature much more dramatically. So water is able to absorb heat without its temperature changing much. So then in the reverse, when the temperature cools and the sun is not generating as much heat, the water can turn around, release its heat energy to the surrounding environment without its temperature decreasing very much. So why is the specific heat of water so high? Surprise, it's hydrogen bonding. It takes so much heat energy to disrupt the hydrogen bonds between the molecules that the water doesn't evaporate. It's simply the water absorbs the heat, the hydrogen bonds weaken or break, and all that happens is that the liquid water molecules move more freely. In the reverse process, as the water is cooled, the hydrogen bonds reform, releasing heat energy. So what does this mean? Water is slow to heat and slow to cool. And you can see from this slide, this is a map, a heat or temperature map. It's a temperature map of the southern part of the state of California on a summer day. And you can see that those coastal communities, like Los Angeles and San Diego, have much lower temperatures than communities on the interior of California. San Diego and Los Angeles are sitting in the mid-60s, while poor Palm Springs on the edge of the Mojave Desert has temperatures approaching 100 degrees. It's because the high specific heat of water helps to moderate the air temperatures around those coastal communities. It's the specific heat of water that also aids in evaporative cooling in any organism that can sweat. The water in your body absorbs and releases heat to help keep the body temperature constant. So when you sweat, those individual liquid water molecules break free from the others and evaporate. In order for that to happen, in order to break those hydrogen bonds and for evaporation to occur, energy must be absorbed. Well, the energy is absorbed from your body. That's the source. That's why sweating helps to cool you down. One little detail, the energy that it takes to evaporate a substance, so to turn it from a liquid to a gas, to a vapor, is called the heat of vaporization. And once again, the heat of vaporization of water is very, very high. It's the amount of energy needed to convert 1 gram of a liquid to a gas, and it's very, very high relative to other substances because you have to break those hydrogen bonds in order to convert liquid water to gas water. One more thing, behavior of ice. Solid water. Water is very unusual in that the density of its solid state is less than the density of its liquid state. This is why ice floats. Most solids sink in their liquid. Solid water floats. This is critical for the maintenance of life on Earth. Bodies of water freeze at the surface, which means that there is still a liquid layer beneath the protective sheet of ice. This protected liquid layer assists the other living organisms from freezing, and it allows them to survive cold snaps when the surface temperature is so low. So just to recap, water is unique and wonderful because of these strong hydrogen bonding attractive forces between the molecules. It results in strong cohesion, strong adhesion. It allows for the moderation of temperature, which keeps temperatures, environmental temperatures, within livable limits for other organisms. And solid water floats on liquid water, so bodies of water don't freeze solid. In the next module, we talk about water as a solvent.